Go ahead.
Page, I'm sorry.
Alright, page 50. So we're going over the SNE quiz. So number 1 is asking questions and defining problems. That'd be for science and then for engineering. So,
Okay, now you have to differentiate though between science and engineering. So what does science do?
science is asking questions.
And engineers?
Engineering is defining problems.
Yeah. So were there any questions and lack of clarity on on that one? Because that's an important one. Remember, because we're asked to include engineering, but we're not told what does that mean, and so this gives some clarification, if you would, about what engineering might look like in your classroom.
Problems have solutions, right? But scientists aren't asked to look for solutions, just merely report what they found. Engineers are asked to,
The way it is.
yeah, engineers are asked to answer questions that have definite answers.
No, not questions.
Not questions.
Defining problems and solutions.
I mean, those can also have questions. A question is also a problem. Like if you were to give someone an assignment, like, oh, how many questions, how many problems would you have for?
Well, no, I want you to go back and to reread after today and make sure you're clear on this, because when you're talking to other teachers, you have to be using the same definitions for words. So if you use the standards, then that you can always go back to the standards, certainly to clarify our understanding of it, but also for the other teachers that you're working with, because most of them are probably not going to be aware of the framework.
What if this is our operational definition?
What if the definition you have is your operational definition?
Kind of like.
Is it consistent with what the standards say? Is it clear between what science does and engineering does?
Okay, I think this is a question of meaning versus semantics, right? So if your answer isn't verbatim what they say, but it gets the same message across, bueno, right? Okay,
At this point, yes.
cool. Then cool.
It's good to know.
Yeah.
Okay. Then
So I don't know if your operational definition did though.
Wouldn't that be your operational definition? Is something that you came up with yourself that is the definition?
Oh, you mean your definition is an operational definition because it's yours and not directly from.
Isn't that
I
what
hadn't
that
thought of it
is,
used that
right?
way, but I couldn't argue with it.
But that's what you're supposed to do.
But that's
right?
what you were just talking about on the last quiz, defining operationally.
Right, but it's not a link to this definition here.
Yeah.
It's not a link to these practices.
So we have to, never, just keep.
I just confused
Okay.
you guys so
Keep
much.
going.
Okay, number 2.
Let's forget about that term, operational definition here.
Alright, number 2 is developing and using models. So, you could use that for both science and engineering. There's not a specific.
And here's what I would suggest that you start doing is get a copy. I don't know if you want to do paper, you want to do electronic copy, but when it starts on page 54, getting to that third level of scaffolding, start thinking about the kinds of models. That would be on 56. About what kind of models would occur in the courses that you're certified to teach. So in other words, what?
I said I've got a lot of them.
Yeah. Well, I think all of you probably do, but you have to think about it. So in other words, you need to translate this kind of generic definition into your world. And you can do that by making notes about what kind of models. So yours page might be a model of a cell, and yours might be the model of an atom, or yours might be the model of an atom too. You see what I'm saying? So you're talking about what all kinds of models would be there, not just physical models, because that's important to understand. Okay, go ahead.
Alright, 3 is planning and carrying out investigations.
Thank you, teacher.
Are we moving on, or?
And and the language they use is investigations for both scientists, science and engineering.
Okay.
Yeah.
4 is analyzing and interpreting data, and that's again for both science and engineering.
But notice the first sentence in both of those. It says scientific investigations produce data that must be analyzed in order to derive meaning. Engineers analyze data in the test of the designs and investigation. This allows them to compare different solutions. See the language, how it shifts there a little bit? Okay, go ahead.
Number 5 is using mathematics and computational thinking. Again, that's both for science and engineering.
Okay, and you had a question between that and, which one was it?
Because
8?
the definition of 5 says statistically analyzing data.
Mm-hmm.
So wouldn't that be an analyzing and interpreting data? Like, how are these two things different?
They just like even numbers, so they made 8 instead of 7.
It just seems so.
You can use math and computational thinking to analyze and interpret data.
It seems like that would go first. You
Yeah.
know,
But you could also, I guess, just a
they
lot of
both
this.
say statistical analysis.
Mhm.
Both of them. That's the definition for both of them. So
Some-
it's like, what is the
I
difference?
mean,
But
you
you're
can
doing
also just
quali-
use mathematics as in measuring data as well.
And also, what about a qualitative study? You can't use statistics. Okay, most of the time you can't use statistics to gather results from a qualitative study.
So it's either or. So, like you might use one and you're not going to use the other.
I think you're supposed to use all of them.
I would disagree.
I don't know. What do you think is the difference between
Because
these
these are the processes, right? Are these processes?
Okay, well, I think the point that Daniel brought up was pretty foundational in that there are some data that's not gonna be quantitative. It's gonna be qualitative data, which we talked about, remember when we were talking about different types of investigations, okay? So that's definitely gonna be a difference. Do we use math in both of them? Yes, even if you're counting the number of red birds, there's 5, well, that's quantitative, but you're not doing any kind of analysis on it necessarily. Okay.
Alright,
Next.
number 6.
Yes.
Constructing explanations.
Wait a minute, let me go back. Computational thinking is also a kind of a new buzzword, and I think what the standards are trying to do is to clarify that a little bit better. Yes, they're pretty darn similar for both of them, but there is a little bit of difference between them that they are trying to suggest.
Number 6 is constructing explanations for science and designing solutions for engineering.
Because the explanation does what in science?
It answers the question.
Yes, absolutely. Go back to number 1. It answers the
Designing
questions.
solutions helps fix the problem.
It helps to define the
Define the
problem.
problem.
Yeah. Yeah.
Alright, number 7, engaging in argument from evidence.
You have to back up everything you say with.
What is the evidence for your answer?
Exactly.
Absolutely. And you always want to ask that
Oh yeah.
in everyday life. Well, I'll give you an example. I started developing blood blisters, which are, the
Fun.
kind of red spots that I'm seeing here. And so when I asked my primary, I take 81 milligrams of aspirin, which is a common dosage that adults take that keeps the blood thinner so they don't have, heart issues. And then my gynecologist suggested taking CoQ10 because that's an anti-inflammatory and it can also impact your energy. And my primary said, okay, you're taking fish oil, you're taking CoQ10, and you're taking 81 milligrams. Those are all blood thinners. So she said, get off of the 81 milligrams and only the CoQ10, no fish oil. So my husband takes a blood thinner because he has a pacemaker, he's got heart issues. So I started thinking, okay, wait a minute. If he's taking Xarelto, should he also take CoQ10 or not? So I called the heart doctor, and the nurse went to, what's that list, where they have conflicting drugs that will conflict with one another? I forgot what I'm talking about?
Interaction.
Yeah, it's an interaction site to where they'll list a drug and say what interactions it might have with other drugs. And she said she checked it with CoQ10 and Xarelto. Actually, Xarelto and CoQ10 was not listed as an interaction with it. And I said, well, it's still a blood thinner, and I'm not confident with that. So I was asking her the evidence for her answer, and what she gave me, I said, no, I'd rather you talk with a heart doctor about it. Actually, they call him a heart electrician. So it's different from the valves and the mechanics versus the electricians that they have, different specialties. But you see what I'm saying? So in everyday life, you need to ask, what's the evidence for your answer? And and you may or may not agree with it, but you also need to have evidence for your answer. I have trouble with my headaches, and so when I was talking with my primary, the dentist said, I suggested something that needed to be done. I won't go into details to bore you. And he said, no, that's not going to help. And so when I was talking with my primary, I said, my hypothesis, and I use that word, my hypothesis, if this is done, this, could be an impact on the headache. And she said, well, I agree with you. She said, I don't agree with the dentist. So, here I'm trying to find evidence from reputable sources, and that's exactly what you have to teach your students to do. To be thinking and using the science and math that they learn in their everyday lives, because they're not going to be science teachers or scientists or engineers. Most of them are not. So the everyday life. Okay, go ahead.
Which number were we on? The 8? Yeah. 8 is obtaining, evaluating, and communicating information.
Yeah. And that primarily has to do for your students of them writing up their the data at the end of their investigation. We're taught to do that, but most of the times teachers are not teaching students how to do that, and their that last step is not done well. So what are we talking about here? A direct instructional model or an inquiry model?
For 8.
For teaching this to your students, how to do number 8.
Direct instruction.
Pardon?
Would it be direct instruction? No.
Direct instruction or inquiry? Should they discover it, or should you teach it to them in a direct instructional model?
I argue that it depends.
I think
Depends on what you're
I think you should
No, this is what you're
directly.
teaching here,
I think you should directly show them how to do it.
and
so
that's
that,
typically true.
so
That would
that
be
they
a
would
direct
know.
instructional model, because this is a process, and so it's not something they can discover through inquiry. And remember, that's a guideline. It's not a rule for everything, but that's the guideline for it. So you start thinking about which ones that you think wouldn't work, Daniel, and come back to it. Okay, so the reason for you to have to know these better than you do today, that you're going to continue learning, is because you're going to be using them in your 2E, 3E, 5E lessons. Okay, so your lessons should involve most of these practices. Maybe not all of them for every lesson, but most of them for any lesson that involves inquiry. So continue to learn this. So guess what's going to be on your exam?
This.
You're correct. So that's going to, and I have a list from another exam last semester or something. I'll show you what it looks like. I don't ask anything we have not covered. Okay. All right. Any questions on that?
No.
Okay, you're up, Paige.
Do we grade it? Or?
Yep, score it. What do you think you should get? What's an honest score for that?
We'll put them in order. Y'all have to put them in order.
That's right.
Order.
Alright, so.
Is it really that hard when it's 3?
No.
Wait.
It makes, you gotta
It's
make the teacher's
this
job
is-
easier.
This is a pattern that you need to adopt for yourself. Honestly, it's not hard to put 3 into order.
Yeah.
or 4 or 5 or 10 even. Okay, Paige, you're up.
So you guys watched the video last night, I hope?
We don't have that paper still, do we? The
No.
questions that's with Megan.
Yeah. So there were a lot of people who don't know a lot about a lot of stuff, apparently.
You know, it really, when I watch these videos, it really gets me to thinking, I'm like, if someone asked me, would I know these answers, you know?
Mm-hmm.
Say stupid answers to obvious stuff.
Yeah.
Yeah, I think it's just relative to what you know, what
Mhm.
Anyway.
I think experience plays a big thing into it, right? Like there's definitely kids that can get the concepts if they've had that common experience of being in a really like pitch black room where there is no light. And also getting the idea that we only see stuff because the light bounces off of it. That's what I was thinking. Like I feel like they think that every object just kind of
Has
radiates.
its own light.
Or I guess that okay, if you told them that, they'd be like, no, that doesn't make sense. But that the color of it, it's a wave. It's a light wave. Yeah.
I think I turned it on.
Oh, you did turn it on. I want to make
Okay.
sure. Okay.
Good.
Yeah.
Let's talk about the light thing, right? But yeah, so you could have told this, and what I got from it is like you can tell the student, hey, light bounces off objects and goes into our eyes, and our eyes take that information and send it to our brain. That's how we see. But then if you ask the question, okay, if there's no light in the room, can you see anything? Students, even though told something contrary, will still rely on, it's not even really a gut or instinct, but it's like experience. Like I've been in dark rooms before, I know what happens. This is duh, right? Like we can see stuff because it's dark, but we can still.
Your eyes adjust. It
Yeah.
just takes a minute.
Mm-hmm.
Not if there's not a source of light.
Well, yeah, I'm saying like what the students thought.
Yeah.
She was
Like-
convinced even after
So-
like 10 minutes. She's
Yeah.
like, just wait.
Just
Yeah.
wait.
It's good.
What are the big ideas though that you should take from that video? There's a couple of big ideas. One of them was one that started with the introduction, the 20-minute introduction video you saw.
Just knowing. Just because you say something doesn't mean that your students are going to.
Oh, telling is not teaching?
Yes.
Did we hear that today? You told me, I told you, and you said, well, I don't know it, right?
Mm-hmm.
Telling is not teaching, okay? That's one big idea. What's the other?
Something that's obvious to you is not obvious to other people.
Why is it obvious to you?
Well, that's just their wording. I wouldn't necessarily say it like that, but
You
Well-
might have experienced it, but they haven't.
What?
You might have experienced what?
You might have had what?
Experience.
And where do we get experiences to understand fundamental science ideas?
Observations in life.
And
the classroom.
in science classrooms, yeah.
Hopefully.
Yeah, so if you are doing a light unit, then what, I mean, does that give you some information about how you might structure the unit?
Mm-hmm.
About what kind of physical experiences students need to have to understand it? Yeah, that's one of them. Anything else? Any other big ideas in there?
I feel like I kept repeating kind of the same sentiments as the previous private universe videos with the whole telling is not teaching. I think that's been an overarching theme,
Yeah.
which I guess is your way of introducing us to the concept of guided inquiry versus direct instruction. Like that's
Well, no, direct instruction is okay for
Yeah,
a
yeah.
product or a process.
I'm not saying it's bad or anything,
Yeah.
but I'm saying like a lot of
It
people
has its place.
and a lot of people I feel like, especially from our generation, have grown up with lecture. Like lecture is the hallmark of how people learn. And when we've been told that our entire life and our grades have been based off that and our ability to adapt to that, we think, oh well, if I can do that, then I'm a good teacher, right? Because then they get the good grades and they move on. But
Okay, let's go back to get to the good grades. How would they get a good grade through lecture? How would you
Regurgitation.
assess? Huh?
regurgitation.
Yeah, but how would you assess that? What would your test look like, or a quiz look like if you
Oh.
were
Selected
lecture?
response.
What?
Selected response.
which means what?
Like multiple
choice.
Okay,
Or even like a fill in the blank kind of thing.
possibly, yeah. So, I'll tell you one story and then I want to get to another one. Remember when we talked about how I had given students a online multiple choice test on natural selection? And I gave them the same kind of test items on a written test, and then I asked them in an essay to explain natural selection. They got all of those multiple choice items correct. They did not get that essay correct. That essay was what revealed their lack of understanding or misunderstanding about it. So guess what happened when y'all's, what was it that you had an online quiz and all of you made 100, and then when we came back in and I asked you, I gave you another quiz or asked you to write down something, I forgot what it was.
Was that the school board quiz?
No, it was,
Okay.
no, it was something online, but my whole point was that none of you made 100, but you made 100 on that multiple choice test online. So there's real problems with using technology and thinking, oh, this will be simple, I'll just do it online. Because that was not a good assessment. And I did that deliberately as an example for you guys, because assessing what students know that's fundamental in teaching. I will know how much you have learned up to this semester when you start planning your lessons, because I've given you all the tools,
I'm terrified.
and now you have to use them.
I'm terrified.
It's not that bad.
No, I'm terrified because of her. She's gonna brutally hurt me.
Okay, so go ahead, Paige. You want to finish up the private universe discussion then?
Good job, everybody.
Yeah.
Like, what kind of closer do you want me to do?
Well, what you're supposed to do when you're leading a discussion is to ask pretty probing questions. You're supposed to ask what, how are you as a leader, the teacher, going to know whether or not the students understood, first of all, the fundamental ideas, and then what kind of sub-ideas or sub-components should they have understood with the experience, whatever the experience is, whether it's watching a video, doing a lab, or whatever, or any kind of assignment.
Okay, so we
Okay.
asked about main ideas. How would you guys use this in your classrooms? Daniel,
What?
non-volunteer.
Good job.
So rather than just lecturing to people, I would either devise a worksheet or an activity that would ask the students to perform some sort of, I don't want to say experiment, but like a procedure or something that gives them that common experience of whatever topic we're discussing.
And where would you find that over here?
That's a very concrete thing.
Yeah, so you would have them experience a concrete with hands-on, so to speak, okay?
And then,
That's not gonna be a worksheet.
I mean,
She
it
doesn't
can
like
be
the
guided by
worksheet.
the worksheet.
Okay, please don't ever mention worksheet in my presence because it makes me really ill, because they're so bad.
Why? What would you call a sheet that they work on? What would you call
Well, it depends on what they're doing with it. If they're just filling in the blank, listening to a lecture, that's a worksheet, and that's not good instruction, that's not good
Yeah.
teaching.
I
But
don't
like
think that's
the-
what he's talking
Well,
about.
that's not, worksheets can ask critical questions for students to have to think about and answer. If you give students magnets and nails and ask them to magnetize the nail and ask them questions about how that interacts with a compass and ask them, what are your observations?
Like
what
a
is this?
guideline?
Yeah, like it guides you through guided inquiry.
And it's not a
No.
worksheet.
No, it's not, but guided inquiry uses worksheets.
No, they do not.
Yes, they can though.
It's just
What is
a
Pogle
name.
then?
Okay, let's go back to what Paige just said. Let's agree it's a name. And if you talk to other teachers in your discussions about planning lessons and you talk about using a worksheet, they are not going to think about a guided investigation.
What if they show you, or if we show them the worksheet and it's not fill in the blanks?
Do you assume?
Well, okay, let me say this, and then we're coming back to this. This won't be the only time. If what a worksheet means is not good teaching or learning.
Is it
Okay.
just
And,
busy?
hold on, let me finish. And so if we use that term for something that does not mean poor learning, poor teaching, then people are not going to understand it. So the language that we use is important. That's why these standards, using this language, is important to learn how they say it and the kind of language that they use.
So it's also assuming every single teacher, when you say worksheet, thinks of that way of
They do.
instruction. But we don't know. You don't know that.
I know that it is ubiquitous across the nation about how teachers are using worksheets, and when they go to iPads, it's just an electronic worksheet. It's not any different than writing it on paper. This weekend I read some research about how prevalent those awful worksheets are. I mean, it's not just me saying it. These are researchers everywhere.
And I would agree, and I think most competent educators would agree. But is there a different term other
No,
than
I would
work?
not agree with that, because if they're
What
everywhere,
you just said?
no, if they're everywhere, then they're not competent educators who are using worksheets. If it's a guided inquiry, what would McDermott say, Dr. McDermott say? Would she ever call anything that she puts out of the worksheet?
I don't know what she would refer to it as.
Dr. McDermott is the guru for physics inquiry.
But I don't know what she would exactly call it.
Haven't you seen those physics by inquiry
They call them
labs?
tutorials.
Huh?
They call them tutorials, is what I've colloquially known them as.
Do you have copies that you could bring in we could look at?
Yeah, I have a whole book of them.
Oh, good. Would you do that? And then we'll come circle back around to that.
Because
Okay.
they are, in essence, a sheet of paper that students work on. It's
Let's agree to disagree at this point, and we'll come back, okay? All right, go ahead. Anything else?
You guys have anything else?
no, I don't feel like arguing anymore.
Okay, maybe we should just,
That's right. That's what. All right. Okay. You're going to lead the discussion on the standards chart.
get out yield standards chart.
I
Daniel.
left it at the old bachelor pad.
Well, maybe you could look on with someone.
Alright, so she gave us this nice filled out one.
I love it so much. If I can find it. Where is it?
Is it four?
Okay. Look in your table of contents. Where should it be?
It is in 4.
Yes.
Alright, so
Okay, what about this?
when we were young, we did the benchmarks, remember? I thought they were, I could have sworn, was benchmark the name of the test, the standardized test at that time too?
No,
You took the
no,
Still
bench-
pass. Or still
It was
pass.
TOS.
Well,
There
that
was toss and then
We're
tax
going to
and
come
then
back to that. It is no, it's not the same.
Okay.
So you're talking about a publication that's called
the standardized test.
The benchmarks of science
for science
or
literacy,
Yeah.
ESL benchmarks for science literacy. So it is a book.
something. Okay, so it was 26 years ago
The
and
date.
1993.
That's on your test. The correct name and the date is on your test.
So you guys need to know the dates, 1996, 2012, or 2011 for framework, right? 2013 for HSS.
I thought we already went over this
I thought
because we
The
did.
total one?
We went over
That's
all
what
of
I asked y'all earlier,
Yes,
because I
'cause we
couldn't
did-
remember if we had or had not.
Yeah,
We
thought
discussed that we need to know the name, the date, the authors, pretty much everything. The grade breakdown, misconceptions,
Where the misconceptions are found,
mhm,
not the misconceptions.
where they're
Wait, we don't need
found.
to know the misconceptions themselves?
No, we
No.
just need to know where they're found.
Well, you will for your lessons, but not for this.
And then if it's whether it's curriculum or performance based, and then how the themes are listed or where they're listed.
Well, let me back up. Not necessarily the themes and where they're listed, but there are themes in all of those publications. And if you look at them, they're ways of organizing. So there's this vast amount of information, so it's just ways of organizing them. Because we're gonna, when we start looking at the framework and the NGSS, you're gonna see them again.
Okay.
So the idea of the consistency, no matter whether it was 1993 or 2013, all of them are consistent.
Okay, then yeah, we did go over this.
That's it, okay. All right, I'd like for you to get out now your teaks, your little teaks.
I
And,
never got those. I think Chris is the only one that has them, right?
I have them.
Okay, then I never got a copy of those.
We're just missing what, elementary school, middle school.
okay, Crystal, let me show you.
I was gonna erase some
Oh,
of this.
come with me, I'll show you where they are.
You're struggling today.
Coming. Take a lap. Come on, take a lap.
And wait a minute, put it off, good.